Hello everybody, I'm Suman Matthews and today we will be discussing derivative as a rate measure. This is a part of grade 12 mathematics and the NATA eligibility test for architecture. This channel has videos for grades 11, 12 engineering maths, the NATA aptitude test for architecture and the GRE quantitative section. Do consider subscribing to my channel for more videos or visit my page. You can also enroll for my online classes for grades 12 and NATA maths. Here we learn how to calculate the derivative as a rate measure, the rate of change of volume of a cube when the edge changes, the rate of the increase of the length of the shadow as it moves away from a post, the rate of increase in the depth of water being poured into a cone, and the rate of increase in the length of a kite string. So if y equal to fx and delta x is the change in y, in x then delta y will be the change in y. So dy by dx is defined as limit as delta x tending to 0, delta y by delta x. Here dy by dx represents the rate measure of y with respect to x. If y increases, dy by dx is positive. If y decreases, dy by dx is negative. Coming to problems, if an edge of a variable cube is increasing at the rate of 3 cm per second, at what rate is the volume increasing when the edge is 10 cm? The volume is x cubed, where x is the edge of the cube. So what is dv by dt? It is 3x squared dx by dt by chain rule. So now we are given that the edge increases at the rate of 3 centimeter per second. So dx by dt is 3. So dv by dt becomes 3x squared into 3. And we need to calculate dv by dt when x equal to 3. So that is 3 into 100 into 3, which is 900 centimeters squared per second. Question 2. The total revenue in rupees received from the sale of x units of a product is given by Rx equal to 3x squared plus 36x plus 5. Find the marginal revenue when x equal to 5. The marginal revenue is given by ddx of total revenue. And what is derivative of the revenue? 6x plus 36. And we have to calculate the marginal revenue when x equal to 5. So marginal revenue when x equal to 5 is when you substitute x equal to 5. We get 6 into 5 plus 36, that is 66. Coming to question 3. A girl of height 1.6 meters walks at the rate of 50 meters per minute away from a lamp which is 4 meters above the ground. How fast is the girl's shadow lengthening? So this is the girl and this is a tower. And using similarity, we can say that 4 by x plus y is 1.6 by y. And dx by dt is 50 meters per minute. Why is that? Because the girl is walking at the rate of 50 meters per minute. And this is the rate at which the girl is walking. So dx by dt is 50 meters per minute. Now, cross multiplying this, we get 4y equal to 1.6x plus 1.6y. Or 2.4y is 1.6x. So y is 2 by 3x, that is 1.6 by 2.4. So what is dy by dt? 2 by 3 into dx by dt. Dx by dt is 50. So it is 2 by 3 into 50, which is 33 1 by 3 meter per second. When the world says no, you try again. So just keep trying. That is the key to success. A circular cone with semi-vertical angle 45 degrees is fixed with its axis vertical and vertex downwards. Water is poured into the cone at the rate of 2 cm cube per second. Find the rate at which the depth of the water is increasing when the depth is 4 centimeters. So this is a circular cone. And what is the formula for volume of a circular cone? 1 by 3 pi r squared h. Now you are given that the semi-vertical angle is 45. So this becomes an isosceles triangle because this is 90. So r equal to h. So we can replace r by h and volume is 1 by 3 pi h cubed. So dv by dt will be 1 by 3 pi 3h squared dh by dt. And dv by dt, if you go back to your problem, we are given that water is poured into the cone at the rate of 2 cm cube per second. So what is dv by dt? 2 cm cube per second. you put h as 4. So I get 2 equal to pi into 4 squared dh by dt. So dh by dt will be 1 by 8 pi centimeter per second. Coming to the next question, a kite is moving horizontally at a height of 151.5 meter. If the speed of the kite is 10 meter per second, how fast is the string being let out when the kite is 250 meter away from the boy who is flying the kite? The height of the boy is 1.5 meter. So this is the height of the boy and the height of the kite is 151.5. So this is 150 and you are given that. Going back to the question, the kite is moving horizontally. So it is moving in this direction. Now using Pythagoras theorem, if this is x and L squared will be x squared plus 150 squared. L is given to be, so we differentiating with respect to t. What do we get? 2L dl by dt equal to 2x dx by dt. Derivative of 150 squared is 0, being a constant. Now x squared is 250 squared minus 150 squared. You are given that L is 250. So x will be 200. Now substituting in this equation, what do we need to find? We need to find how fast is the string being let out. So I need to calculate dl by dt. Now dl by dt from this equation is x by L dx by dt. dx by dt is 10 meter per second because the string is being let out at the rate of 10 meter per second. This is x. And L is 250, x is 200. Substituting, we get dl by dt is 8 meter per second. So we have learned how to calculate the derivative as a rate measure, the rate of change of volume of a cube when the edge changes, how to calculate the rate of increase of the length of a shadow as it moves away from a post, the rate of increase in the depth of water being poured into a cone, and the rate of increase in the length of a kite string. So do consider subscribing to my channel for my videos or visit my page and feel free to send me your feedback. Thank you.